So in general organic chemistry, the important areas what we have to understand is that first reaction mechanism. Okay. Suppose if we take this two types of plots, in this case now we are seeing enthalpy versus progress of reaction. The enthalpy of reaction versus what? Progress of reaction. Enthalpy means what? Delta H. Enthalpy change of reaction versus progress of reaction. We are taking the graph here. So in this case, now it is the enthalpy of what now? Reactants. Enthalpy of reactants. And these are products here. So it is what now here? Enthalpy of products. Enthalpy of products, enthalpy of reactants. It is HR. Enthalpy of reactant. It is what? H product. Enthalpy of product. So enthalpy of product, enthalpy of reactant. Okay. And whenever reactants are converting into products, here what is formed? Activated complexes. This compound is what? Activated complex. And this activated complex also has some energy now. Yeah. This is called here threshold energy. What is called? Threshold energy. So threshold energy is nothing but the energy possessed by activated complex. It is one type of reaction in which reactants first convert into activated complex, and activated complex will finally change into products. So this type of mechanism is called what? Concerted mechanism. Concerted mechanism includes what? Formation of activated complex only. Only activated complex will form, and no formation of intermediate. No formation of reaction intermediate. Okay, only it will be formed. Yeah, now check it by yourself. So what is the type of reaction called here? Concerted mechanism. Concerted mechanism. That is formation of only activated complex. Is that clear, ma? Next, in second type of reaction, check. So these are reactants and these are products here. Now when reactants are converted into products, first what is formed here? Activated complex is formed. What happened? Reactants first converted into activated complex. After that, activated complex will change into what? Reaction intermediate. This is in the reaction. Okay. So again, the reaction will change into another activated complex. And this will finally change into product. So in this graph now, in this graph, how many troughs are there here? It is crust, CREST. CREST crust, it is trough. So how many maxima, how many minima here? One maxima is there here, one minima is there here. So this loop indicates, this point indicates what? Reaction intermediate. So this position always shows what? No, reaction intermediate. Now if you compare with the energy of reactants and reaction intermediate, which one has more energy here? The intermediate has more energy than what? Reactant. Is that clear, ma? So in this type of reactions, they are called non-concerted mechanism reaction. Non-concerted mechanism reaction and concerted mechanism reaction. In the non-concerted, what happens? The reactants first will change into activated complex. Activated complex will change into reaction intermediate, and the reactive intermediate will finally change into product. So these two types of organic mechanisms will be there. In some reactions, only activated complex will form. In some organic reactions, activated complex and reaction intermediate both will be formed. So two types of mechanism will be there in organic reaction. Is the concept clear, ma? Tell me in non-concerted what will be there? Reactants convert into activated complex. Again, activated complex will change into reaction intermediate, and reaction intermediate will finally change into product. But in concerted, what happens? In the concerted reaction, reactants will change into activated complex. Activated complex will change into product. So these two are important types of mechanisms. And whenever you take any organic reaction, we have some electronic effects which have to be understood. What are they called? Electronic effects. Should be understood here. Electronic effects means displacement effects. Electron displacement effects here. Means electrons will be displaced from one place to other place. Sometimes sigma electrons will be displaced. Sometimes pi electrons will be displaced. So the displacement of electrons will take place in the reaction, the reactant molecules and product molecules. Suppose if you take any organic reaction, first what will be there? Substrate means reactant. It will be attacked by what? Attacking reagent. Attacking reagent. So whenever attacking reagent attacks the substrate molecule, what will be forming? Intermediates will form sometimes. Sometimes first activated complex. Again, activated complex will change into reaction intermediate, and reaction intermediate will change into product. Lastly, products will be formed. So this is organic reaction. So in this substrate molecule, the substrate molecule, okay, some electronic displacement reactions will be, means some electronic displacement effects will be. The electron displacement effect will decide which type of attacking reagent must be attacked. Generally, attacking reagents what? Electrophiles and nucleophiles. E plus means what? Electrophile. Nu minus means nucleophile. This electrophile is what? Electron deficient. Nucleophile is what? Electron rich. Electron rich. And electrophile is what? Electron deficient. So which type of attacking reagent will be attacking this substrate will be decided by some electronic displacement. So in these substrate molecules, what will occur? Electron displacement effects will be there. So how many types of electronic displacements I told you? Inductive effect, electromagnetic effect, electromagnetic effect. Third one, mesomeric effect. Mesomeric effect is also called resonance effect. Capital M, otherwise capital R. R indicates resonance, M indicates mesomeric effect. So inductive effect is one type of electron displacement effect. Second one, electromagnetic effect. Third one, mesomeric effect. And fourth one, hyperconjugation. Fourth one is what? Hyperconjugation effect. So these four are what? Different types of electron displacement effects which will occur in substrate molecule, that is reacting molecule. So based on which type of electron displacement effect is there in the molecule, the attacking reagent will be decided. Which type of attacking reagent can be attacked? Suppose if the substrate molecule is having negative charge. Suppose if the substrate molecule is having negative charge at one point. This negative charge will be attacked by what? E plus. E plus means electrophile. Electrophile will attack on the negative part of this substrate molecule. Suppose if the substrate molecule is having positive charge at one point, due to this electronic displacement effects, in substrate molecule, suppose positive charge is developed at one point. This positive charge will be attacked by which one? Nucleophile. The nucleophile will be attacked. Nucleophile will be attacking on what now here? Substrate molecule. Is that clear? Okay. So it's about what now here? The electron displacement reaction. See, understand my concept here. The substrate molecule will be attacked sometimes by electrophile, sometimes by nucleophile. Okay. So based on what it will be decided here, based on what this attacking will be decided, because of this negative part of this substrate molecule and positive part of this substrate molecule, different types of attacking reagents will be attacking the substrate molecule. Then we'll get first activated complex in some reaction, and sometimes reaction intermediate will be forming and products will be forming. And what are the reaction intermediates here? Carbocation, carboanion, and carbon free radicals. A C dot indicates what more? Free radical. Carbon with one electron is called free radical. Carbon with negative charge is called carbanion, and carbon with positive charge is called carbocation. So carbocations, carbanions, carbon, free radicals. These all are what now here different types of reaction intermediates. Suppose if the reaction is having what now carbocation. In one reaction, carbocation is formed as a reaction intermediate. Suppose in that case, we have to say carbocationic mechanism. If carbanion is formed as a reaction intermediate, that will be called carbanionic mechanism. If free radical is produced, that is called free radical mechanism. So like this, different types of reaction intermediates will be there, which are what now carbocations, carbanions, carbon free radicals. So finally, these reaction intermediates will interact with each other to form what? Products. So this is organic reaction mechanism. So in that, we have to understand what now electron displacement effect means electronic displacement. Okay. So in that, first one is what now inductive effect. First one is what now inductive effect. Is that clear? So inductive effect is there. See now, electron withdrawing groups in decreasing, okay, minus A. Again, this inductive effect is of two types now. What are they? Positive inductive effect and negative inductive effect. So electron withdrawing groups means capital I groups. Capital I groups in the decreasing order of what? Minus I effect will be like this. Yeah. So now here minus I effects will be there and plus I effects will be there. Two types of effects will be there. Now minus I group second first one. See R3N plus will be having highest minus I effect. Minus I effect means electron withdrawing effect. Remember, minus I effect is electron withdrawing effect. Next NO2. NO2 means nitro group. Nitro group is having more than what? CN, cyano. Cyano has more effect, minus effect than COOH. COOH more than fluorine, chlorine, bromine, iodine. So among the halogens, you check it here. Fluorine more minus effect than Cl. Cl more than Br. Br more than iodide. So these all a methoxy. OCH means methoxy group and hydroxy group. And phenyl C6H5 is what? Phenyl group. So these all are what now here? Minus I groups. So important groups are given here. Very important groups are given. These remember. So this is the order of what now here? Minus I groups. Minus I group is what? Electron withdrawing group. And next, electron donating. Electron releasing means what? Electron donating groups. So these electron donating groups in the order of decreasing plus I effect. A plus I effect means what? Positive inductive effect. So the positive inductive effect will be highest for bond O minus. Bond O minus ion. Greater than bond COO minus. Bond COO minus. Greater than tertiary alkyl group. Tertiary alkyl group meaning what? The carbon attached to three other carbons. How many CH3 groups in this? Three groups. Means what? Carbon is attached directly to how many methyl groups? Three. That's the tertiary carbocation. Tertiary alkyl group. And it is what? Secondary alkyl group. Here, how many CH2 groups available? Two. That means the carbon is directly attached to other two carbons. So it is secondary, 2 degree. And it is primary. In this propyl it is CH3, CH2, CH2 means propyl. And CH3, CH2 is what? Ethyl. And CH3 is what? Methyl. So among the propyl, ethyl, methyl, which one has more plus I effect? Which one has more plus I effect here? Propyl. Why propyl has more plus I effect than ethyl group? Because the propyl group is bulky group. The propyl group is what? Bulky, heavy group than what? C2H5. C2H5 is bulkier than methyl CH3. So which is bulky group here? Heavy group here? CH3, CH2. So sorry, propyl is more than ethyl. Ethyl is more than methyl. Okay. The concept clear. So it's about what now here plus the effect. Electron is right here. Next, if you check now here, see. Now this is E effect. E means what? Electromagnetic effect. Electromagnetic effect means what? See here between carbon double bond is there. In this double bond, one sigma bond is there, one pi bond is there. In the pi bond, electrons are called pi electrons. Now pi electrons and sigma electrons both are available here. Only pi electrons will be shifting towards any one carbon. The pi electrons will be shifting to one carbon. Suppose the pi electrons are shifting which side now? Right side. Now right side carbon gets which charge? Negative charge. And the left side carbon gets what? Positive charge. When the two pi electrons shift towards carbon right side, the right side carbon gets negative charge. Left side carbon gets positive charge. Now, what is attacking reagent here? Attacking reagent is what? H plus, positively charged. It is what now? Electrophile. H plus is what? An example for electrophile. Electrophile meaning what? It is electron deficient. Electron deficient, electrophile is taken here. So this H plus electrophile, okay, will be attracted towards what? C minus. The C minus will attract what? H plus. C minus will be attracting what? H plus here. Then H plus will be attached to right side carbon here. To the right side carbon, what is attached here? Hydrogen is attached. Now, the left side carbon has got which charge here? Plus charge. So the plus charge is there on the left side carbon. On the right side carbon, H plus is attached. So we got one intermediate compound here. In this intermediate, in this reaction intermediate, carbon is having positive charge, right? If carbon is having positive charge, it is called what now here? Carbocation. Carbocation is produced. So this carbocation is what now? Reaction intermediate. The reaction intermediate is produced. Again, this will finally change into what? Product. The reaction, this carbocation will finally produce what? Product. So it is electromagnetic effect. In this electromagnetic effect, check it now. Now pi electrons are moving towards right or left here. The pi electrons are moving towards right. And attacking reagent also right side or left side. The attacking reagent is also on the right side carbon. And pi electrons also moving towards right side. So the effect is called plus E effect, positive electromagnetic effect. If transference of electrons, transference of pi electrons occurs towards the atom where attacking species attaches. Now, this atom, carbon atom, to which attacking species attached here. The attacking species is what? Hydrogen. The hydrogen attached to this carbon on the right side. The pi electrons also transfer towards which side? Right side. The pi electrons transferred right side. The attacking reagent is attached right side. So this is called plus E effect, positive electromagnetic effect. And second type you check it. The second type now, between carbon and oxygen, one sigma bond is there, one pi bond is there. And the pi electrons will be always moving. Remember, when sigma and pi bond there, pi bond is weaker. So pi electrons will be displaced here. Now between carbon, oxygen, which is more electronegative atom? Oxygen is more electronegative than carbon. When oxygen is more electronegative than carbon, what happens now? The two pi electrons will move towards oxygen. The two pi electrons will be moving towards right side. Now right side oxygen gets negative charge. And the left side carbon gets what? Positive charge. When pi electrons are moving towards oxygen, okay, oxygen gets negative, carbon gets positive. Now, what is attacking reagent? Check it here. Cn minus. Cn minus is attacking reagent. Means nucleophile. What is it here? Nucleophile is attacking reagent. This nucleophile will be attracted towards what? C plus or O minus? The Cn minus will be attracted towards what? C plus. Because unlike charges attract each other. That's why what happens now, C plus is forming here. Okay, and O minus will be there and C plus will be there. The C plus will attract what? Cn minus. Then what is forming? The Cn is attached to carbon. The cyanide attacking reagent is attached to which atom? Carbon atom. And still there is negative charge on what? Oxygen. Still there is negative charge on oxygen. So O minus will be. So like this, one species will be developed here. Okay. So this is what minus E effect. Minus E effect. So in this effect now what is happening? Check it. The effect is called minus E, means negative electromagnetic, if transference of electrons occurs away from the atom where the attacking group attaches. Now attacking group is attacking group Cn minus will attach to which atom? Carbon. But pi electrons are going away from carbon. The attacking reagent is attached to carbon, but pi electrons are going away from carbon. That's why this effect is called what now? Minus E effect. Minus E effect meaning what? Negative electromagnetic effect. So negative electromagnetic effect, positive electromagnetic effect. So two types of effects will be there. Okay. Next. Now differences between inductive and electromagnetic. Here E effect, I effect. Here it will be plus I and minus I will be there. Here also plus E and minus E will be there. Now which is permanent effect here? Inductive. And the electromagnetic effect is what? Temporary effect. And it operates only in the presence of what? Some polar bond. Polar bond means what? Generally carbon Cl bond. Carbon gets Cl gets negative charge, carbon gets positive charge. And this bond is called what now? It is called a polar bond. So whenever polar bond is there, in that case only the inductive effect will be taken. Next, the presence of multiple bond. The molecule is not essential here, not important. Double bond need not to present. Simply one polar bond should be present. Next, electromagnetic effect operates in a molecule containing at least one multiple bond. Here multiple bond should be present. The presence of multiple bond is essential here. So the presence of some polar bond in a molecule is not essential. Here polar bond not necessary, but multiple bond is necessary. Here polar bond is must, but multiple bond not necessary. Next, presence of attacking reagent is not required. Any attacking reagent like electrophile or nucleophile not required here. But here the effect takes place only under the influence of attacking reagent. Attacking reagent may be electrophile or nucleophile. Anything should be there. Electrophile or nucleophile, anything should be there for electromagnetic effect to take place. Why it is called temporary effect here? If you withdraw this electronic means electrophile or nucleophile, immediately the reaction, the effect will be neutralized. Means the effect will be reversed. The electromagnetic effect will be reversed when you withdraw what? Attacking reagent. The presence of attacking reagent only, the electromagnetic effect will take place. But here in inductive effect, there is no requirement of any attacking reagent. Next, the effect means inductive effect involves what? The partial displacement of sigma electrons. Remember, which electrons are moving here? Sigma electrons are moving, displacement. Not complete displacement, partial. Incomplete displacement of sigma electrons will be there. And the electromagnetic effect involves the complete transference of pi electrons. Means pi electrons will completely transfer from carbon to oxygen. The pi electrons will move completely from carbon to oxygen. A complete transfer of pi electrons will take. But here only what happens? Displacement will be there. Now the two electrons of the bond will be displaced towards chlorine, but not leaving the carbon atom. Still in the carbon atom only there these two electrons, but the electrons will be close to what? Cl. Next, in inductive effect, the displaced electron pair does not leave its molecular orbital. Means from the carbon, the two electrons will not be completely going to Cl. Still, the two electrons will be in the orbital of carbon. That is the meaning here. In electromagnetic effect, the displaced electron leave their orbital and take a new position. See, between carbon oxygen, the two pi electrons are completely going from carbon and entering into orbital of oxygen. Means these two electrons are leaving from the orbital of carbon. Next, in inductive effect, partial charges, partial means partial negative charge, partial positive charge. Partial charges are developed on atoms and no ions are formed. A completely like Na plus ion will not be formed here. Like Cl plus ion will not form here. But Cl will get what now? Partial negative charge. Cl will get partial negative charge, that's all. But complete ion will not be formed. The ion will not form. This partial negative charge will be developed, that's all. In this now, in electromagnetic effect, there is complete charge separation. There is complete charge separation and ions are formed. So between C and O, what is forming? A O minus will form completely. C plus will form. A complete transfer has taken place now. A delta we need not write. Partial negative we don't say. Complete negative charge will be formed. So this is about what now here? Inductive effect and electromagnetic effect differences. Next, if you take mesomeric effect. Mesomeric we say or resonance. Mesomeric effect or resonance effect. So what do you mean by mesomeric or resonance effect? So here, what happens now? Now the same structure is nothing but benzene only. We know benzene molecule with alternate double bond. Alternate double bond. Okay. Suppose if you take here, it is what now here pi bond, single bond. Again pi bond, single bond. Again pi bond, single bond. So here this is carbon here. It is sp2 carbon. This is also carbon. Again sp2 carbon. In every sp2 carbon, there will be empty p orbital. Here one empty p orbital is there. Here one empty p orbital is there. Between two empty p orbitals, what will be forming? Pi bond will be formed. One pi bond will develop between p orbital of sp2 carbon, again p orbital of sp2 carbon. Between these two, what is forming here? Pi bond is formed. Already between carbon, one sigma bond is there. sp2 orbital of carbon, again sp2 orbital of carbon. Formed already what? Sigma bond. Then between p orbital and p orbital, what will be forming? Pi bond will be formed. That is, the pi electrons are not stationary here. The pi electrons will be moving to this place. These pi electrons will move here. These will move here. So continuously electrons will be delocalizing here, moving inside. So this is called delocalization of electrons. So the delocalization of pi electron clouds. So orbital picture of our benzene showing the ring-like electron clouds. In benzene molecule, so above the plane and below the plane, there will be electron cloud. This electron cloud is due to what? Movement of pi electron. Delocalization of pi electron. Is that clear? So it's about what now? This delocalization of pi electrons is due to what? Resonance. Due to resonance, the delocalization of pi electrons will be taking. And this effect is also called what? Mesomeric effect. Now here, if you take this one, buta 1,3 diene. This molecule is what? Buta 1,3 diene. In this, alternate double bonds are there. The double bond, single bond, again double. So here pi electrons there, here pi electrons there. So pi bond and pi bond at alternate position na. So this is called pi conjugation. What is called? Pi-pi conjugation. If there is pi-pi conjugation, when two pi bonds are at alternate position, so these pi electrons will move to this carbon. Okay. Again, these pi electrons will move to next single. Right. Again, it will give rise to what now next structure? CH2, single bond, CH, double bond, CH, single bond, CH2. Here, these two pi electrons coming to carbon now. The two pi electrons are coming to right side carbon now. The right side carbon gets negative charge and left side carbon gets what? Positive charge. So because of this pi electrons movement, what happened? Negative pole, positive pole developed. This is polar species now, polar charged species. And the first one is neutral species. So because of this pi-pi conjugation, what happened here? The resonance occurs. Which process occurs here? Resonance. Resonance occurs due to what? Resonance will occur due to what? The pi-pi conjugation in this molecule. So due to pi-pi conjugation, the pi electrons only will be displaced from one place to other place. So in this buta 1,3 diene molecule, resonance occurs due to pi-pi conjugation. Means the electrons will be moving like this, moving through all the orbitals. Here sp2 carbon, sp2 carbon, sp2 carbon, sp2 carbon. In every sp2 carbon, there will be one p orbital, like this. So between all the p orbitals, among all the p orbitals, the pi electrons will be displaced. The pi electrons will be moving. So this is what now here resonance. Is that clear now? It is mesomeric effect. And see here. Now in this example, in this molecule here, see, it does not show resonance. Though pi bond and pi bond at alternate position. See, pi bond is there, single bond. Again pi. Pi-pi conjugation is there. What is there? Pi-pi conjugation is there. But resonance will not occur. Pi-pi conjugation is available in this. Pi and pi bonds at alternate position. But resonance is not taking place. Delocalization of electrons does not occur here. The reason what? See, here this is what bulky group here. Here C attached to how many carbons? CH3, how many times? 3 times. The carbon is attached here. This carbon is attached to how many methyl groups? 3 methyl groups. So it is what now here? This is tertiary alkyl group. Tertiary alkyl group is what? Bulky. Bulky group means what? Heavy group. It is a bulky group. Because of these two bulky groups, heavy groups, the delocalization is not allowed here. Okay, so double bonds are not in same plane. Both double bonds will not be in the same plane. If both double bonds are in the same plane, in that condition only, the delocalization of pi electrons will take place. But here, due to the bulky groups, due to the bulky alkyl groups, what happened here? The two pi bonds are not in the same plane. Both are in different planes. In that condition, though pi-pi conjugation is there, the pi electrons will not be delocalized. Means mesomeric effect does not occur. Resonance will not be there in this reaction. Means in this type of compounds. Now see here, pi-pi interaction and a negative charge pi interaction. A negative charge versus pi. It is what? Pi bond versus pi bond. Pi-pi interaction, negative charge versus pi bond. Here, a pi bond is here, one pi bond is here, one pi bond is here. So when pi bond at alternate position, the resonance will take place. And this type of interaction is called pi-pi interaction. Due to this, negative charge is developed here, positive charge is developed here. In this case now, pi-pi bonds not there, two pi bonds not there. Only one pi bond is there. One pi bond is there. And also, suppose here there is what now here? Lone pair. So it is what now here? Suppose negative charge you take this one. Okay, suppose it is lone pair.